Okay, now I'm start open the ATENA center. I am go to documentation and open the ATENA engineering 3D tutorial. And also I'm go to the my following research paper and I'm open the ATENA 3D. This is my workspace. This is the main workspace. Okay. Now I'm following instruction of the ATENA 3D tutorial and my at my research papers data. Okay, the first step is tutorial. They show their designing beam. They in the software they design half of the beam, and this is our research paper, which we going to design. They show the dimensions and concrete properties. Now we follow the steps of TENA 3D. There they say to analyze the information under general data. Under the general data, there is analysis information. Global, there you have to give description and not. And there you can give the force beam 3D. And in my research paper, there is beam with shear reinforcement. Then I add the note beam with shear reinforcement. Okay. In solution, you have to select standard. Okay. Now they say to save the file. You save as and Factrix. I give the name Factrix. So yes. Now I'm going to add my materials. There path is input data tree, then data material. Now you have to add. First we are going to add the steel plate. Add definition and you have to add material. You have to change 3D elastic isotropic. Next, then the title steel plate and the elastic modulus. There the Q 2.1 to the power 5. We have to add same the elastic on our beam also because my research paper didn't mention our steel plate elasticity. I add same thing. Next, we have to add reinforcement. There also that property I add the same thing which is in the tutorial because they didn't especially mention the reinforcement details also didn't mention. If I find it, I can edit also our properties. Input properties we can edit. I do same the things which is mentioned in now I do same the things. There I change type binary class CT and FI also change. Now finish. Next I have to add concrete of the beam. There 3D non-linear simultaneous 2. Next there cubic FU is which is given in our set paper. There 40 megapascal temperature resistance. They're given. Then we have to add this one 40 megapascal. According to that 40 megapixel, they give the properties of according to that 40 they change the properties of that other properties they give. We have to input that same data because we don't have that data. In the tutorial they give the which we have to change data, but they in our research paper they didn't give. Then I add the same the things which is given by our software, and there we have to change concrete. And if you do same beam which is in the tutorial, you have to edit this data which is mentioned in the special mention which you want to change. Now I'm going to construct our beam. Then there I have to go input data tree, topology, concrete construction cases, micro element add. And there you have to give, firstly you have to construct your beam. There, entity type, there in the small box new object, there's a box. You have to add the data. The entity type, column beam, coordinator system global, reference point is orientation that symbol 0, 0, 0. The size Vx, Vy, Vz. There Vx is length of span of the beam, full length of the beam. Vy is width of the beam. Vz is height of the beam. There they give their beam length, width, and height. Then you have to go your one, our beam. Then my beam full length is 2200 millimeters. Then there we design half of the beam. Then I add a one-time click and 1.1 meters. There we have to add data in meters. Then you have to specifically remember you have to put tick. Otherwise they didn't add your data. And By is I said is the width of the beam. Then 150 millimeter dimension. It means 0.15 meters. And height of the beam 300 millimeter. Then 0.3 meter. Then you can press the side dimension generate button and one click. This is your beam. Then you at the beam your main window and then you can close it. This is your beam, concrete beam. Then you have to do a steel plate next. You also you mention your first micro element is your beam. Then next you have to do add the steel plate. Then steel plate also you have to go again topology, micro element, add. And there they especially mention some coordinates. Let's see what are these. Okay, they give parameters of our steel plate. Origin is in the 3D tutorial, x is in 0.165, which means there, this is the origin. In the xy plane, xz plane, this is their origin. So in there, then we have to check where is our one. Let's see. There in mention, our span is this one. Your span length is this one. And our cross section is this one. I already had. And our main reinforcement is this one, 16 millimeter, and top reinforcement is 10 millimeters bars, and our stirrup is 8 millimeter. This spacing is 200 millimeters, and our PO span is 2000 millimeters, and our shear span is 667 millimeters. Here, the depth ratio is 2.5. What is shear span? Shear span, we can set it. Shear span is distance between the center of the support and the nearest point where the load is applied. Between there to there, distance they give. Then we want half of the beam length minus dash length is equal to our x value. Then we will see our beam half of the length is to 100 and 1100. Then I minus 100 because our support is in there. It's mean 1000 minus our shear span is 667. Then that this data, this x value is our 0.333. I add this one. This table is bring from edit grid is bring from the offset your toolbar toolbar. There is mentioned that this mark, this icon, you have to click that button and the x is 3.33. And this set there, these values are give the thickness that origin to how much you have to move another point. There I at the same point which is give the tutorial because the steel plate dimension didn't give in our research paper. Then y value is same, which is start from the there, and z value there first you have to give height of the beam, yes. Our beam height is 300, which means zero point 0.3, and thickness is 0.3. Now we have to add that points. Join def. Then now we have to go to the next step, joins definition. Then here we have to go there, see a and types the joint at the joint, and there we have to add this coordinates. Let's see what is that coordinate. In first, we are at that middle point of our uh, steel plate. Now we have to input the data of that steel plate of what are the corners of that steel plate. Then we have to give the coordinate of that points, all the points. Now let's add, they give their steel plate that this below points. Now their big middle point to that corner point, they uh, assume their thickness as 0.05. Then firstly we give, you remember, uh, 0.333. Now we have to minus 0.05 of from this. Then 0.333 minus 0.5, 0.05 plus on this 283. Y coordinate is 0 because that corner, this point there is our point, this their y coordinate is 0. Then Z is along the beam. So in this point now. Then we have to add height of the beam there. Our beam is 300 millimeter, which means zero point 0.3 millimeter. And then next point is this point. Then same x value, but thickness is more than uh, more than 3, which means 0.3, 0.03. Right. Then next point is this one, which we given in our data. That middle point, 0.3330, there, same. Then we have to get data from there. Then now 0.333 plus 0.05, there 0.383. And now another point in there, last point. Now we add 5 points. It's fine. 1, 2, 3, 4, 5. Okay. Next step is we have to draw a line through it. Okay. Now we have to draw line, add. Here we have to give order. Like first start from 4, then from 3, and now start from 3, 2, and then 2, 1, 1, 5, 5, 4. Now go to the surface and at the surface it says 1 to 5. Now you have to go general solution. The surface number is number 1. Global axis is y. Size 0.19 meter. Let's see what's mean of size. They mention size of they mention size. Its uh, meaning is thickness of the beam. Our beam thickness is 150. Then there 0.15. Now we have to add generate. Then add. You can close it. You can see in your main window that steel plate is added. Now there is another steel plate in the bottom, which is the support. Then we can copy it. Another point is in there you can see the US steel plate also add as a micro element. Then we can copy that is plate into there as a support. Then there we have to go topography and micro element select copy. Before that, we have to select that micro element first. Okay, after select this, color is changed and go to the copy Then there shift and wait, let's copy. We have to move it along the y-axis, and our shift value is the support value. Then our the dot point to the value is shear span is 667. Then we have to add 0.67 tick mark and copy. Now we have to move this steel plate in the below. Then we have to again go to macro element. Third one, we have to select third one. After that selection, that third micro element color is changed. Then go to the move and shift the bottom of the beam. Then it is thickness of your beam. Move length is this. uh, I think didn't select my micro element. It's about long. Then I go again, select move. You have to go to the operation as a mirror and XY plane and shift. There you have to move half of the beam thickness, 150. Then move. The next place in the bottom of the beam. Now there you can see, you can off the content and you can uh, content surface. Then you can see your steel plates. Then next we go to the mesh generation.